Hello friends, welcome back to the tutorial. Our next topic is regular expressions to NFA. We know that regular expressions represent regular languages which are accepted by some finite automata. Now, for each regular expression, we have a finite automata which accept the language represented by that regular expression. Now see, empty string is a regular expression. Now, the finite automata corresponding to this regular expression can be this one or this one. Now look at this finite automata. Here, there is an empty transition from initial state to final state. It means without reading any input symbol, machine will jump from initial state to final state. And look at here. Here, the machine's initial state is its final state. It means without reading any input symbol, machine will remain in final state. So these both automata accept the language represented by this regular expression. Now, second regular expression is phi. The regular set corresponding to this regular expression is this one, a set with no element. Now this finite automata accept the language represented by this regular expression. Right? Here in this automata there is no final state. It means this finite automata will not accept any string because here there is no final state. So whatever you apply, it will remain in this state Q1, right? It will never jump to any final state. So it will not accept any string. So this is the finite automata which is without final state is corresponding to this regular expression phi. If A is any input symbol of any finite automata, that is A belongs to sigma, then A is also a regular expression. Now the regular set corresponding to this regular expression A will have only one element, that is A. Now this is the finite automata corresponding to this regular expression. There is only one transition from initial state to final state which is labeled by A, right? So this finite automata accept only one element, that is A. Now suppose R1 and R2 are two regular expressions. M1 is a finite automata corresponding to the regular expression R1 and M2 is a finite automata corresponding to the regular expression R2. Q0 is the initial state of M1, Q-0 is the initial state of M2, and these are the final states of M1 and these are the final states of M2, right? So M1 will accept all strings which belong to the language represented by regular expression R1, and M2, finite automata M2, will accept all strings which belong to the language represented by regular expression R2. Now we have to design a finite automata corresponding to this regular expression R1 plus R2, right? Now the regular set corresponding to this regular expression will have all the strings which belong to the regular set corresponding to the regular expression R1 as well as to the regular set corresponding to the regular expression R2, right? So what we have to do, make a new automata which will accept all strings which belong to the set represented by this regular expression. So it means we have to design a finite automata which will accept the strings of regular set represented by R1 as well as the strings of regular set represented by regular expression R2. Now what we have to do, design a new finite automata. Let's say its initial state is Q1. Now from this initial state, add empty transitions to the initial states of M1 and M2. Now here in this new finite automata, initial states of M1 and M2 are not initial state of this finite automata. Q1 is the initial state of this finite automata, right? And final states of M1 and M2 will be the final states of this newly designed finite automata, right? When there is a some string which belongs to the regular set of R1, then what happens? Without reading any input symbol, machine will jump to Q0, which is the initial state of M1, and on reading that string, machine will jump to any final state of M1, which is also the final state of this newly designed finite automata. So that string will be accepted by this finite automata. Now suppose there is a string which belongs to the regular set of regular expression R2. Then what happens? Machine, without reading any input symbol, will jump to Q-0, which is the initial state of M2. Here it is not initial state, right? Then on reading the string, it will jump to the final state of M2, which are also the final states of this finite automata, newly designed finite automata. So in this way, the string represented by the strings which belong to the regular set represented by R2 will also be accepted by this newly designed finite automata. Now we have a regular expression R1, R2. Suppose R1 is a regular set, capital R1 is a regular set corresponding to the regular expression R1, and capital R2 is a regular set corresponding to the regular expression R2. Now, what does this regular expression represents? This regular expression R1, R2 represents the concatenation of regular set R1 and R2, which is a set of strings formed by concatenating the strings of set R1 with the strings of set R2, right? Then we have to design a finite automata which will accept all the strings which belong to this set R1 concatenation R2. What we have to do? First, make the initial state of M1 the initial state of this newly designed finite automata. We have to design a finite automata for this expression R1, R2. Its initial state will be the initial state of M1. Now make all final states of M1 non-final and add empty transition from these non-final states which were the final states of M1, right? Add empty transition from these states to the initial state of M2, right? And final states of M2 will be the final state of this newly designed automata, right? So its initial state will be the initial state of M1 and its final states will be the final states of automata M2, right? So a string which is formed by concatenating the string of R1 with the string of R2 will be accepted by this finite automata. first it when it reads a string, suppose there is a string AB, right, where string A belongs to set R1 and B belongs to set R2, regular set R2, then obviously this string will belong to R1 concatenation R2, right? So when we apply this string on reading input string A, right, on reading the string A, machine will jump from initial state to these states, which are the final states of M1. Here they are non-final states. And without reading any input symbol, then machine will jump to this state, which is the final initial state of M2, right? And then it has to read this string B. When it reads B, it will jump to the final states of M2, which are the final states of this newly designed automata. So in this way, string AB will be accepted by this finite automata.